We have a geometric progression where S represents the sum to n terms, P represents the product of the terms, and R represents the sum of the reciprocals of n terms. So we need to show that S over R raised to the power of n, that's equals to P squared. So let's begin. First, we will need to specify the first term and the common ratio of the given GP. So let the first term be A in lowercase, and we're also going to specify the common ratio, and the common ratio be represented by the letter R in lowercase. So here we are given that S represents the sum of n terms, so S will be equals to A times R raised to the power of n minus 1 divided by R minus 1. So this is number 1. Then P, so P is actually the product of the terms. So that means we have our first term is A, which will be multiplied to the second term, which is A times R. Then we have the third term multiplied to it, AR squared. This goes all the way up to ARN minus 1 times ARN minus 2 multiplied to ARN minus 1. Right. So that means we have A times A times A. So this is getting multiplied to itself n number of times. And so this whole thing is also multiplied to R times R squared. This is getting multiplied to itself n minus 1 times. Therefore, we will now have A times A multiplied to n times, so simply A raised to the power of n. Then we have R raised to the power of 1 plus 2 plus 3 all the way up to the n minus 1 terms. But therefore, we will now have A raised to the power of n multiplied to R. So here this is an arithmetic series whose sum is given by the formula Sn equals to n over 2 multiplied to 2 times A plus n minus 1 times the common difference D. So in our case we have our first term, that's so here we'll have n minus 1 term, so we have n minus 1 divided by 2 multiplied to 2 times the first term, so that's simply 2, plus we have n minus 1 minus 1, so we'll get n minus 2 multiplied to the common difference, which is simply 1. That means we now have A raised to the power of n times R. So 2 plus n minus 2, that's simply n. So we have n times n minus 1 divided by 2. So this is the product of the terms. So let's label this as equation number 2. And then we have R. R represents the reciprocal of the sum of the term. So that means our first term, the reciprocal is 1 over A. The second term will be reciprocal of the first term, 1 over AR. Then we have 1 over AR squared. This goes all the way up to n number of terms. So here the first term, so our first term is 1 over A, and the common ratio R is 1 over AR. This is the second term divided by the first term. That means simply multiply it to the reciprocal of the first term. So our common ratio will be 1 over R. So that means the sum will be R will be equals to 1 over A multiplied to 1 minus 1 over R raised to the power of n divided by 1 minus 1 over R. So this time we are using the formula that Sn is given by A times 1 minus R raised to the power of n divided by 1 minus R, assuming the R value is less than 1. So simplifying this, we're going to get R equals to, so here we have R minus 1 over R, so 1 over A divided by R minus 1 divided by R, or this is simply equals to R divided by A times R minus 1. So we have R divided by A multiplied to R minus 1 times R raised to the power of n minus 1 all divided by R raised to the power of n, which will be equals to R raised to the power of n minus 1 divided by A times, so we're combining this R and this R, so this will be R raised to the power of n minus 1 multiplied to R minus 1. So this is the value of our R. So this is equation number 3. Now that we have the value of S, P and R, so let's start from the left hand side. So on the left hand side we have S divided by R, so we'll take S first, which is A times R raised to the power of n minus 1 divided by R minus 1. So this is divided by R. So that means we are simply going to multiply it to the reciprocal of R, which is A times R raised to the power of n minus 1 multiplied to R minus 1 whole divided by R raised to the power of n minus 1. And this entire expression is raised to the power of n. So here R raised to the power of n minus 1 is n from the numerator and the denominator cancels out. So we have R minus 1 also cancelling out, and this is leaving us with the value a squared. So we have a times a, that's a squared, multiplied to r raised to the power of n minus 1 whole raised to the power of n. Or simply we have a raised to the power of 2n times r raised to the power of n minus 1 multiplied to n. Now we can also express this as a raised to the power of 2n multiplied to r raised to the power of n times n minus 2 divided by 2 multiplied to 2. Or we have a raised to the power of n times r raised to the power of n multiplied to n minus 1 divided by 2 whole raised to the power of 2. And we've already obtained this value within the parentheses, so that value is p. So we have p squared. This is the right hand side. Hence we have successfully showed that this expression is true. S over r raised to the power of n equals p squared.